and get started, and I will introduce our next speaker. Joining us today is JoDee Peyton, and she is an environmental health specialist with the Benton-Franklin Health District. JoDee has been with the health district for over 23 years, working in land use, water, and sewage program for the past 20 years. She is also a qualified sanitary survey inspector for small public water supplies and has been inspecting these water systems for over 15 years. So JoDee, thanks so much for joining us today.
Thank you. So today my topic is septic systems and wells, the maintenance and care of them. So we're going to start off with septic systems. Again, if you have any questions, you can write them in the comment section, and we can try to set some time in between septics and wells, and I can answer septic systems at that time and then move on to the well portion of this presentation and then take those questions at the end too. So to start off with, there are about 4 parts of an on-site sewage disposal system. As you can see in the diagram before, you have your house, and all the wastewater from that house is going to go into the septic tank, which is right there off the house. That is where you're going to get a lot of settling of solids. The next part is the water will go to a distribution box, which will then send it out to your drain field. And a lot of people don't think of the soil as being a part of your system, but it actually is. It helps determine the size of your drain field and what kind of system that you need. So the minimum size septic system that is typically in homes, and this is any new homes, from 1975 on, it was a 1,000-gallon tank minimum. Before that, there's a lot of strange tanks out there. A lot of them, you can see 750s sometimes or 500s, but today the minimum size tank for any home is a 1,000-gallon tank, and that is good for up to 4 bedrooms. After 4 bedrooms, you will have an additional requirement of 250 gallons per bedroom. So this slide is just talking about the different parts of the septic system, the distribution system, the drain field, the soil, like I went over already. The purpose of the tank, here is where the sewage, the water from the toilets, the sinks, the kitchens, the bathrooms, the showers, is all going to come into the tank. Since 1978, 2 compartment tanks have been required. And this helps allow for the settling of the sludge, which are the heavy solids that sink to the bottom, the scum, which is the fats, the oils, the greases, the paper products that form a layer at the top, leaving a liquid level in the middle. You have baffles in between all the sections of the tank, and this is to allow for the slowdown of the water into the tank, the separation, and then just the liquids moving through and into the second compartment, where you will get some more settling, not as much as the first tank, obviously, and an outlet baffle, which is going to send the water, which is now called effluent, out to your septic drain field. Sometimes there is a filter in this baffle, and it needs to be cleaned out from time to time. It's a good idea in that it will prevent a lot of solids from getting into your drain field and causing the septic drain field to back up, but it does need maintenance. And so every 6 months or so, you need to get into that tank, pull the filter out, rinse it out with water, and you can rinse it out right back into the tank and put it back in, because it will clog this baffle from time to time, and when that happens, water will no longer go to the distribution system and start to back up into the house. So the distribution system typically consists of a distribution box, which can be polyurethane, and also it could be concrete as well. So this is what it looks like if you're standing over it. If you take off the lid, it looks like this. These are the pipes that go to the drain lines. This is the place where the water comes in. And what we look for when we're inspecting it is that the water level is what is level. It's not just the box itself. It's that the water is touching the edge of all the pipes at the same time, so that when new water comes in, it goes out equally to the distribution in the drain field. So this is a mock-up of a drain field that was built above ground, so people could kind of see what it was. So this is a concrete D-box. This is your perforated pipe. Down here, this is what the perforated pipe looks like. And these holes are typically drilled at 5 and 7. And they need to be facing down so that the water that's coming down these pipes will fill and go into the gravel that the pipe is placed in. Sorry. So the trenches are typically 3 feet wide. You have 6 inches of gravel, a 4-inch pipe, and then another 6 inches of gravel with a filter fabric. And that filter fabric is pretty important because it prevents the soils from becoming clogged by all the fines in the soil. And then over the top of that filter fabric, you'll have about 12 to 24 inches of cover soil. Something that's coming in common these days are gravelless trenches or chambers. And those are basically like a plastic tunnel that they hook together. They're in 5-foot sections and they get hooked together. You have the bottom of the trench, which is level, and that's where the pipe comes in, and it just spills that water into the trench. And those are becoming more and more common. We're not really sure if they're better than gravel or not. So far, all the research shows that they are just as good as gravel, but they haven't been going in long enough for us to get a good idea of if they will last longer than gravel or not. It's only been in about the last 20 years or so that they've really become common, and a typical drain field will last between 20 and 30 years. So another method that people can use are the septic aerators, and those are usually put into the tank to mix oxygen in that water because aerobic bacteria that uses air is much better at breaking down the nutrients and chemicals that are in the effluent. And while they're allowed, they are very expensive, and they usually only go into areas where there is not very much soil and we have to have extra treatment in order for that effluent to meet our standards for what can be discharged into the soil. So, I see that there's another question that if one of these drain lines is clogged or filled in with dirt so that the others have been overloaded and the water has been periodically above ground, can you have it fixed or do you have to have a new drain field? It depends on what the clog is. If it's a clog in the going into the line, if one line is getting all the water or all the dirt, it could be that the distribution box is not level, and that can be remedied, and then the other lines can take over for a while. But it is a sign of failure. Anytime you have water or sewage coming to the surface of the ground, it's considered a public health risk, and that is something that does need to be fixed. And the cost for that depends on whether you can just fix one line because it's been overloaded because the distribution box was tilted, or if it's just the bottom line that just seems to be getting all the water and the others are going to be failing coming up. The cost to repair a system is typically going to be somewhere between $5,000 and $8,000 on up. It just depends on how many drain field lines you need to put in. Typically, when one line goes bad, the others aren't far behind, and then we would have you put in a whole new system. Also, if the system was really old, it makes no sense to put a new line or two on to a system that already has two lines that are overwhelmed. You would just go with another system. And by doing that, you also would allow the old system to dry out, and for a lot of times what clogs the system is a biofilm that forms at the bottom of the trench, which is like a bacterial layer. And once you take away the water from that, that starts to break down and break apart. And over time, that will start to accept water again. So by switching to a whole new system and letting the old system dry out and rest, you can probably come back to that in 5 years, use it for 5 years, go back to the old one, and then just go back and forth for quite a long time. So when I do my inspections, this is what I see for the installation. This is the distribution box. This is another example of that. The green pipe is going out to these drainfield lines. You can see the filter fabric, and I will check to make sure that these lines are level, or if they're not level, they have a very slight slope downwards towards the other end. So the soil, like I mentioned before, is actually part of the drainfield system. And its purpose is to physically and chemically filter out the impurities of the water. And the structure of the soil, whether it's rocks and cobbles, it could be sandy, it could be loam, it could be silt, it could be clay. There's 6, 7 different classifications of the soil. So if you think of the soil like a colander, like a filter, rocks and cobbles is going to filter like a colander would filter, not very well. It's going to get rid of water, great, but it's not going to do a very good job of filtering, versus a loamy sand, which is going to act like a coffee filter, and it's going to take more of the contaminants are going to get stuck in that filter fabric, and cleaner water is going to come out from there. And then that water, which is now cleaner than it was coming in, is going to go into the soil and continue working its way down until it eventually gets into your groundwater. So the type of soil is determined by a test hole. And this hole is typically 8 to 10 feet deep. And we are looking at the structure of the soil. A lot of times people refer to these test holes as perk tests, but this is actually an old term, because a perk test is when they would dig a hole, fill it with water, and then time it to see how long it took for the water to go away. Once the water was gone away, and if it went away in a certain time period, it was considered acceptable for a drain field. That's not the case anymore, because we're not worried so much about getting the water out into the soil. We're worried about the soil, treating it so that it's cleaner by the time it gets to your groundwater. So we're also looking for, in addition to the structure of the soil, is when do we hit water, or do we hit water? Because as soon as you hit water, treatment stops. So whatever is in the water, when you hit groundwater, that mixes with that water, and that could become part of your drinking water. So while we don't want rocky soil, on the other hand, we don't want soil that has a lot of clay. The smaller pore sizes of clay, it does a great job of filtering, it just takes a super long time. And to compensate for that, we make the drain field a lot bigger, like really big. It's astronomically bigger. I don't recommend trying to put a system in clay if you can avoid it at all anyway. So something else that we see from time to time is a dry well. And these were used in older systems. They were typically used in rocky soils, and they're no longer allowed. So if you have one and it stops working, and they usually last for a really long time because they're just getting rid of the water. The water goes from the septic tank into the seepage pit, which is typically a concrete cylinder with holes in it. And out of these holes, it is surrounded by gravel, and from there it sinks into the soil. And like I said, they're usually put in rocky soil, and rocks are really good at getting rid of water. So they will last a long time. However, when they do need to be repaired, they typically need to be repaired with a pressure distribution sandline trench drain field, which will allow for a better filtration with sand at the bottom of the trench before it hits those rocks. So another component of a septic system is the replacement drain field. They don't last forever. Typically, like I said before, they last 20 to 30 years. And it's not uncommon that we've had them last 40, 50, or 60 years either. But you have to have an equal-sized area set aside on your lot to provide for that replacement drain field. And that area has to be protected from future damage. You don't want to be driving on it, planting a bunch of trees on it that you're not going to want to cut down when it comes time to use that replacement area drain field. For maintenance of a septic tank, we recommend that septic tanks be pumped every 3 to 5 years. A lot of this depends on how many people are living in the home and using water. Obviously, the more people that you have, the more solids that are going into the tank, and the more often it should be pumped. Some of the things that you need to check when you are doing a maintenance for your septic tank is the tank itself. It needs to have a watertight seal. And most of the time, the lids are about 6 inches below ground, sometimes more. And when you have to dig down quite a ways to get to the lids, you don't want to pump as often. And it's a lot harder to maintain that system. So we recommend risers, which are these right here, and they can be grouted to a tank with a plastic lid at surface grade that just screws down. And then you can lift that lid, pull a filter if you have a filter on your system, or have it pumped on a regular basis. And these lids do have a gasket that goes around the edge here that helps prevent the gases from getting out and making your backyard smell. And this is kind of what it looks like once it's installed. When you are checking your septic tank for things, you want to check for the presence of baffles in the tank. Those really need to be there. They play a big role in preventing solids from getting into the drain lines. So you're looking that the baffles are there. We look at the water level of the water, and we want to see it on the bottom of that invert, so it's not any higher, and that is a good sign that water is coming into the tank and leaving the tank at a steady rate, and the drain field is accepting the water. Sometimes we'll see a lot of solids at the top of the tank, but when we see them on the top of the baffle, like right here, that's an indicator that the water level in the tank has been high, which is the sign of a failing or failed drain field. Because if it's not taking water anymore, the only place the water can go is higher and higher in the tank. And at some point, that is going to back up into your house, which is not what we want. So one issue that we've been seeing in the concrete tanks is decay. And this is happening in some of the tanks that are fairly newer, from about 2000 to 2010. We're seeing a lot of this. And it's a white, gray, pasty, crumbling debris that you might see on the second compartment baffle. That's kind of where we mostly see it. And it's caused from hydrogen sulfide gas, which is a gas product that's given off by the bacteria that are breaking down the solids. And it is eating away at the concrete. And if you were to take a stick and poke at this concrete, it will just come off in big chunks, if not go through the tank. So if you see this kind of decay around the baffles in your tank, it is time to consider replacing the tank. And you can replace just the tank and leave the drain field alone, and vice versa. If you have a drain field that failed, but your tank's in good condition, you can continue to use the tank, and then you only have to pay to replace or repair the portion that's not working anymore. Another problem that we see with the hydrogen sulfide gas is it literally eats a hole through the concrete at the lid. This lid is anywhere from 3 to 4 inches thick of concrete, so it's pretty corrosive stuff that can do that. Other things that you want to look for when you are looking at the lids of your tank is that there aren't any openings that any extra water can get into your tank, because water from irrigation getting into your tank and going out to your drain field just causes it to fail sooner. So there are some do's and don'ts that you can do in order to make your system last longer. One of them is practicing water conservation to reduce the amounts of wastewater. So shorter showers, shallower baths, fixing leaking faucets, spreading the laundry loads throughout the day or throughout the week is even better, like one load a day, one in the morning, one in the evening, so you're not putting a tremendous amount of water through all at once. Also, reducing the amount of solids that go into the tank, the oils and greases. When you're doing dishes and you cook something that's really oily, you can take a paper towel and scoop the grease up with the paper towel and throw it away. And then when you wash the dish, you're not putting as much grease down into the system. Solids, garbage, a garbage disposal. When someone has a garbage disposal, it's considered the equivalent of 250 gallons is what it adds to your system in solids. So you can buy those small screens that go over the drain as the water runs out, and it'll catch a majority of the solids, and you can throw those away and then just use the garbage disposal sporadically when you get little pieces in there and it's causing the drain to move slow. I have a septic system at my home, and we have a filter on our septic system, and we have to change or rinse out that filter about once every 6 months because of the garbage disposal. And because even though my husband and I are pretty diligent about not using that garbage disposal, we have 2 teenagers who are not so diligent and would rather just run it down the drain rather than pick it up and take it to the trash. So one of the septic tank don'ts is to not use solvents or oil-based paints or toxins that you can put down the drain. Avoid any types of grease solvent drain cleaners. And here's a list of some basic things that you should not be flushing down the toilet. The one thing I do want to bring up are the flushable wipes and baby wipes. Sometimes they'll say flushable on them, and basically that means that they will go down the pipes. They're not meant to be in a septic system. They create a thick layer of the scum at the top of that tank, which can fill up pretty quickly. So this list is things you should not be flushing down the septic system. So one question that we get a lot of is, can I use those additives in my system to minimize so I don't have to pump it as often? And a lot of them say, well, you'll never have to pump your system again if you use this additive. Well, that may be so, but the whole point of those additives is to break down the solids, which creates smaller pieces that take longer to clear out of the water. And so it makes it easier for those little pieces to get into your drain field that causes your drain field to clog sooner. Some of the products are toxic, and you don't want to be putting that down into your septic system. And some of them advertise that they are bacteria or natural yeast and things like that. You don't really have to add them. You add bacteria to your system every time you flush. And while yeast is an organic, non-toxic additive, and you can use them if you want, but if you figure out the cost of them over the course of 3 to 5 years, you're going to spend just as much putting these chemicals or additives in your tank as you will pay to have your tank pumped once. So when your drain field fails, some of the common signs are you get gurgling when it's draining, or the drain becomes really slow. You might get sewage coming back up into the house, especially at the lowest point in the house. Just gravity plays a role there. And the other thing you might see is mushy standing water over the drain field. And this is a sign, definitely a sign of drainfield failure, and you need to look at having it replaced at that time. So the drain field, some of the do's would be to protect it from damage. Don't drive over it, and it's not a driveway, it's not a parking lot, it's not a place to put anything heavy. Think about what your landscaping is over that septic system. You pretty much want to keep it to grass or some shrubbery that keeps its roots in a root ball. You want to keep water-loving trees away from it. The recommendation is trees should be 10 feet away from your drain field. And if it's a water-loving tree, it should not be 20 feet. I've seen willow trees travel 50 feet and invade and ruin a drain field. They'll go in through those holes in the pipes and the roots will just go crazy and block it up. You also can divert drainage from over the drain field. So if your roof drains to the same area where your drain field is, you might want to think about diverting that drainage, because the more water is on the drain field, the less it is able to clean things, because the slower that the water moves through the soil, the more it gets cleaned. And when you think about your plants, when you water them, when your plant is dry, the water takes a long time to soak in. But if you overwater your plant, the water goes right through and comes out the bottom and makes a big mess on the other side. So as I mentioned before, you don't want to drive over or park on your septic system. You don't want to have structures within 10 feet of it. The drain field itself is using oxygen to break down the components of the effluent, and you don't want impermeable surfaces keeping the oxygen from getting down to those trenches. So you don't want to have your structures, and plus you don't want to have a structure so close to the drain field that if it fails, that you might get sewage soaking into the foundation of those structures. So no trees within 10 feet, no pasture animals. A lot of times they're big and heavy and they can damage the systems. Probably not as much of the systems if they're a conventional gravity system, but if it's a mound system or sandline trench system, those are pretty fragile, and pasture animals definitely can cause damage there. Another thing that's really important to know is where your system is. And since 1975, permits have been required for septic systems. So you can request an as-built, which is a drawing of your system. So I put the Kennewick office address. We're not accepting walk-in people at this moment, but you can give us a call, you can email us, and the more information you give us, the more likely we are going to be able to find your system. So have your tax parcel ID number, the property address, roads near the property. If the address changed, that's helpful information to have too. There's no charge for this, and we typically email it out to you the same day that you ask for it. So all of the septic system maintenance and how it works is important, because if the soil does a good job of filtering the water, eventually that water is going to become your groundwater, and groundwater is where we get our drinking water. So at this point, if you have any questions about septic systems, I can answer that. There was a question about a Gravelless tunnel, and it's been filling in with dirt a lot. Not really sure. Like I said, they haven't been around a long time that we have a lot of information that we can give you. I do know that when they are put in softer soil, sandy loam, not so much sand, soils with a lot of structure like a silt loam, animals have been able to burrow in, like gophers, ground squirrels. They'll burrow in and take advantage of those tunnels. Sometimes when those chambers are put down, they have chicken wire laid down on the bottom of them, and then the chamber, and that's to keep the burrowing animals out of that tunnel. So other than that, there may be a break in the tunnel itself. It's kind of hard to see. If you have more questions about this, you can give me a call. My phone number and contact information is going to be the last slide of this presentation. So please feel free to call me at any time. So are there any other questions?
JoDee, there was one question that came in a bit earlier that says, what septic aerators are allowed and how effective are they?
Okay, so we don't really have any one brand that's allowed. And we hardly have any in our counties anyway. Because basically what they do is they are just mixing up that water and causing oxygen to be introduced into the water to help break down the effluent components. They are very effective, but they are very expensive and they're not used very often.
All right.
Okay, well, then let's move on to wells.
Well, it looks like there was one more question that just came in. What needs to be considered for installing an RV dump?
Okay, so we do not allow septic tanks to be used as an RV dump. The reason for this is that in the RV, when it's being used, you're using chemicals to cut down the smell and to help break things down faster. Those are not chemicals that you want to put into your tank to go to your drain field and eventually your drinking water. So, like I said, they're not allowed to be hooked into a septic tank. Not saying that they're not out there and that they haven't been put in later, but they are not recommended.
All right, I think those are all the septic questions.
Okay.
Come in.
Okay, so moving on to wells. So about some facts about wells. About 50% of the people in the US get their drinking water from wells. 2/3 of Washington residents get their drinking water from wells. And for the most part, groundwater is going to be what supplies these wells. So it is the property owner responsibility for the maintenance and testing of their wells. It's not anybody else. The only people that that well serves is typically the family of the owner and no one else. So every well owner should know the location of your well on your lot. So the newer wells that are dug, they have this tag that are wrapped around the casing. And this casing has, tag on the casing has a well number like BMK020 is this one. And that is a way that you can look up information about your well log. Other ways you can get information about the well log is from the driller at the time he drills it. The Department of Ecology has a website that has this search engine that lets you find them. Something that you should consider though is that probably wasn't until the late 80s, mid 90s that they started being really good about having the well logs put into the system. So if you have an older well from like the 40s or the 50s, you may not be able to find records about it. But if you do, you can do just a quick, easy little search, WA for Washington well log, and it will take you right to this page right here. And then you can either search with this information, you can do a tax parcel ID search, or the well tag ID search as well. So that's a pretty handy way to find out the information about your wells. And these are two different examples of what they're going to look like. The one on the left is the newer one, and it will kind of tell you how it was built, what kind of soil it went through, how deep it is. This is the older one that you'll see, and it basically tells a lot of the same information. So ways to maintain your well is to protect it. And the thing to remember is that most water contaminants cannot be tasted, smelled, or seen. So testing is going to be the only way to know that. Some of the causes of those contaminants are going to be anything draining towards your well. So if you're storing chemicals close to your well, that's a potential contaminant. If your septic system is too close to your well, that's definitely a contaminant. And we do have a setback rule that your septic tank has to be 50 feet from a well, and your drain field has to be 100 feet from your well, and as well as any other neighboring wells. Things also to consider are there any flooding in the area? Where's your neighbor's well? When two wells are close together, they tend to produce more water because they're competing for the same water supply. And then, like I mentioned before, you want to have contaminants outside of a 100-foot radius of the well. So animal feedlots, pastures, chemical storage, all should be farther away from your well. Some general precautions is finding out what kind of a well you have. Sometimes the wells are dug, and if you think about it, a dug well, they would just dig a hole until they hit water, and then they could keep digging until their heads were underwater, and that's about as deep as they went. And then think about how you would dig an outhouse. So outhouses and wells right next to each other are not good ideas. The deeper the water table, the more soil the water has to go through, and the more likely it is to become cleaner. So a deeper well is often much more protective than a shallow well. Backflow prevention is if you have a hose on a hose bib and you leave it in a horse trough, if the power goes out and you lose pressure in your system, it's going to suck that horse trough water down into your groundwater well. So the easiest way to prevent that is to maintain an air gap. There's a check valve or a vacuum breaker you can put on your hose bibs that will help with that. Also, things to think about is if there an abandoned well on the property, and was that properly filled in? Because otherwise it's just a straw right down into your groundwater. So well protection with seals. This is an example of a well that's in a pump house, and this is the seal up here. It is covering this opening. This is where the water is going to come up, and then it's going to go back down and into the house. You want to make sure that all these openings here are sealed and that there isn't any way for contaminants to go into the water. So a well cap is another one. These are examples of well caps, and they differ because they don't have that rubber gasket, but they sit on the top. This big hole is where the conduit goes into it, and these screens provide a vent to allow air to equalize the pressure inside the well. And it's really important that these screens are present. That will keep insects and mice and other things out of the well water. So these are some pictures that I've seen out in the field. Right here, you have the opening for the electrical, and it's just an opening. And while you can't see it, all those little black dots are mouse droppings. So mice have been crawling all over this. Another issue with this one is that it's on the ground. The casing should be about 12 inches above the ground in order to help protect it. This one had a conduit that was protecting and shutting off access to the well, but it's come loose, and now you have an opening that goes right down into your water. Your pump houses should not be used as storage shed because you have chemicals. You don't want to keep chemicals anywhere near your water supply. They should be ventilated to the outside, which will help prevent dangerous gas buildup. It doesn't happen this often, but a vent is an easy fix for that. And your pump house should really not be used as a workshop or to shelter animals, because if they cause damage, in there that affects your drinking water. So protecting the well on the outside is the casing. So you want to make sure that the casing is there and it's in good repair, no holes or cracks. Listen for running water. That's a sign that water is flowing back down into the well. That the ground around the casing should slope away from it. A lot of times we see an indent where it will drain the water right into the well itself. And I apologize for the bouncing around of the text. Some of this was from an old slide that you don't obviously see that I had put all this bouncy stuff in there. Anyway, like I said before, the casing should be about 12 inches above the ground. So the only way that you know if your water is contaminated is if you test. And contamination can occur suddenly. And like I said before, you can't see it, taste it, or smell it. The most common contaminants are coliform bacteria and nitrates. Coliform bacteria is a group of bacteria found throughout our environment. If it's present in the water, it indicates a possible presence of pathogens. A pathogen is something that can make you sick. Coliform is a group of bacteria that is common in fecal matter. Not every coliform bacteria is able to make you sick, but if you have it in your water, it is definitely a sign that you have fecal matter in your water and you want to be able to get that out. The acceptable level is none, and if you do find it in your water, you will have to disinfect your well. Nitrates are another contaminant. They come from nitrogen for plants and fertilizer. They come from animal waste, human and animal, and the maximum level allowed in drinking water is 10 micrograms per liter. The health effects of nitrate is an illness called methemoglobinemia, which is blue baby syndrome, which is most often seen in babies less than 6 months old. The nitrates cause the oxygen to not be able to carry as much oxygen, the blood to not be able to carry as much oxygen. And so you just don't get enough oxygen. And in babies, it becomes very evident because they're so small and it doesn't take a lot to do this for them. But they will turn blue around the face like this picture shows. Some subtle symptoms before they get to the bluing is diarrhea, vomiting, inactivity, which when you're a baby, that is a symptom for practically everything. So eventually, though, it will cause the infant to have trouble breathing. This is caused when you are using the water to make the formula that you feed the baby with. It's not as common in breastfed babies. Other groups that may be affected by this are pregnant women. It can cause birth defects. It can cause them to lose the baby, miscarriage soon. It can cause a thyroid disease in anyone. It can increase the risk of certain kinds of cancer. So you just want to be careful and know what the nitrate level is. All right, thank you. That concludes my well maintenance. I do know that there was a couple questions in the chat. One of them was about, is there anything I can do to reduce the iron content of well water? Probably going to have to get something like reverse osmosis or a water softener in order to take that out. Sometimes you have to chlorinate the water as well. That might be able to get rid of the iron content. It is not a health issue, but it's more of an aesthetic issue. And then another question that someone had was about alternative waste treatment like outhouses and composting toilets. What's allowed? We will look at those at a case-by-case basis. An outhouse is not allowed, but the composting toilets we will consider in certain circumstances. And again, in all the time that I've worked for the health department here in Benton County and Franklin County, I can't think of anyone that's currently using a composting toilet in their primary residence with a permit. There's probably people using them without a permit in cabins and things like that, but we're not aware of them. Okay, Melissa, do you have any other questions?
Yeah, I see just a couple more. Did we touch on the sulfur smell? Someone had a question, what works for sulfur smell?
Actually, it sounds crazy, but chlorination works on sulfur. So if you chlorinate the water, it will help get rid of that sulfur smell. Sulfur is pretty common in the soil. So as the water goes through the soil, it's getting cleaned up, but it's also picking up things too. And one of the things that it picks up is sulfur. So basically filtration of some sort is, or chlorination is how you're going to get rid of that.
Okay. So we probably have time for about one more question. Someone has a question about shallow wells. This person has a very old well. The table is a shallow well. The table is about 20 feet down. The well is maybe 35 to 40 feet deep. A development is going in across the road, and dry well water runoff collection is being installed. And their concern is about the dry wells, whether those will contaminate shallow groundwater.
They shouldn't, because they're collecting runoff. They're not collecting waste from a house, but it's shallow, and anytime you have a shallow well, that is a cause for concern. You know, if you got your well log, you could see if there was anything between 20 feet down and the 35 to 40 feet deep. If there was a layer of basalt, that might help be protective. I would recommend that they would test their water for nitrates and bacteria. The recommended testing schedule for bacteria is once a year, and nitrates is every 3 years.
All right, great. Well, actually, before I switch over, I just see one more question here. Dosage for treating the sulfur smell, I believe.
I don't know that because it's going to depend on how much sulfur is in your water, and that's going to be a testing issue. Again, that's an aesthetic issue. It's not a health issue. So the water softener, water filter people should be able to help with that and know what that dosage would be.
All right, perfect. Well, thank you so much for joining us this morning, JoDee. I learned a lot from your presentation, so thanks for your time. And if folks do have more questions, I can provide this contact information in a summary report. You can also contact me, and I will reach out to JoDee. But I think we captured everyone's questions today. So thanks again, JoDee.
Oh, you're welcome. Thank you.
All right, so I will go ahead and share my screen.